Seen in a store, you might think this is a 3D printed prop, but Romanesco is biological, a leafy cousin to cabbage and Brussels sprouts. Look directly at it from above, and the organic chaos of a normal vegetable disappears. The head is wrapped in highly organized, unbroken spirals. Trace these paths to find exactly 13 clockwise spirals and 8 counterclockwise. They appear together for a reason. Both are consecutive steps in the Fibonacci sequence, a mathematical pattern where each number is the sum of the two before it. This sequence dictates the architecture of many living things. You find the exact same numbers governing the distribution of seeds inside a sunflower, or even the intricate scales on a pine cone. A plant doesn't know how to calculate equations. To see how a mindless organism flawlessly executes advanced geometry, we have to look closer. Snap off a single floret from the base of the Romanesco. You are left holding a perfect miniature replica of the entire main head. Break an even smaller piece off of that floret, and you get the exact same structure again. This repeats down through several physical levels, right up to the limit of what your eye can resolve. This property, where a shape looks identical at every scale, is called self-similarity. It is the defining feature of a fractal. This diagram shows the construction of the Cox snowflake, a classic mathematical fractal. It builds infinite complexity by repeating a simple triangular shape endlessly onto itself. Romanesco applies this exact logic biologically. It builds a physical, biological body using an infinitely repeating mathematical rule. If we strip away the mature florets and look only at the microscopic new buds forming at the tip of the plant, the mechanism behind this shape emerges. This chart illustrates the golden angle. Every new bud sprouts exactly 137.5 degrees from the previous one. The graph above shows the math. Fibonacci ratios converge on the golden ratio, 1.618. Divide a circle by that ratio, and you get precisely 137.5 degrees. Nature relies on this highly specific, irrational angle because it guarantees that no two buds will ever perfectly align with each other, no matter how many layers grow. By ensuring the leaves never overlap, every single floret receives an unobstructed path to the sun. The engine driving this perfection is located at the absolute center of the growing tip, the meristem. Here, the plant secretes a growth hormone called auxin. The plant is bound by one strict chemical rule. A new bud can only form in the space with the lowest concentration of auxin, which is always the spot furthest away from the older buds. That simple chemical spacing automatically pushes the newest cell cluster precisely 137.5 degrees away from the last one. The complex math is a strict byproduct of biological survival. Zooming all the way out from the meristem to the mature florets, we see that the Romanesco isn't performing calculations. It is mindlessly running a highly efficient set of biological rules driven by chemical distribution. Evolution spent millions of years testing physical spacing for optimal light absorption. It arrived at the exact same sequence of numbers human mathematicians would define centuries later. The result is a physical record of that evolutionary success. It is mathematically optimized architecture, sitting quietly in the producile.